I got it.
Right, so we started mortgages today and we have a question on the screen already, which we answered. So let us move on to a second question, giving us a little bit more practice. A townhouse is on sale. Calculate the amount borrowed if the deposit is 12.5% of the sale price. So what they are saying is your deposit is 12.5% of, I did not put the price of the townhouse. So this is for $150,000. So we have to make a deposit of 12.5%. So we know that's 12.5 over 100, right? Multiply by 150,000, right? So that is $18,750. Now, of course, the amount borrowed would have to be the difference, right? So the amount borrowed will have to be the sale price of the house, $150,000, subtract the deposit, which is $18,750, which is equal to?
It was like if you're calculating the outstanding balance.
Second. Yeah, something, yeah, like calculating the outstanding balance. But the outstanding balance is what you would have to borrow. So that's why we're calling it amount borrowed. Yeah.
Which part asks for the amount borrowed? Which question?
Right, so we had to work out for the amount borrowed. So we subtracted it, the cost of the house, subtracted the deposit. So let's work out part two. If the deposit was 17.5%, now we work out the deposit, which is 17.5 over 100 multiplied by $150,000, which will give us $262,500. $26,250, and the amount borrowed will be, well, we subtract it, right? So $150,000 subtract 26,250, which is 123,750. Hold on. Yeah. Any questions? All right, so we have another example on the screen. A condominium is on sale for $25,000. It is possible to buy by making a 10% deposit and taking a bank mortgage. Calculate the deposit. So we know the deposit is 10%. So we work that out. 10 over 100 multiplied by 275. Which will be, how much is that, y'all? How to work out 10%? We could work out 10% without even going to the calculator.
Cross all the zeros.
Mm-hmm.
We just say 1 by 2,750.
So
And we add a zero to that.
2750, we add a 0, 27,500. Right. Nice. So the amount borrowed, of course, is the cost of the house, subtract the deposit, which is 275,000, subtract 27,500, which is 247,500. All right, the total amount paid to the bank if monthly installments of 3,403 are made over a 25-year period. So the amount paid to the bank will be 3,403 multiplied by 25 by 12, right? Because every 1 year represents 12 months. So that will be
300 for the 25 by 12.
3,403 by 25 by 12.
It's a fat number. 1
It's a
million,
number.
1,020,900.
I didn't know a number could be fat.
Could we use scientific notation here or no?
No, just leave it because it's money. Yeah.
Let's move.
So 1 million is 1 million. Put it on. 1,020,900, right? So part D now. They didn't ask for part D, but let's put what was the total amount paid for the house. And of course, it's what we paid to the bank plus our deposit. So amount paid to bank plus the deposit, which is so almost 1,050. All right, 1,050,000 almost. So $1,048,400. Any questions? So moving on to our first example of rates, we're going to work out a water rate bill, right? So Mr. De Silva's water usage was 105 meters cubed, and the breakdown of the water rates by the company as follows: $2.50 for the first 25 meters cubed, $2 for the next 50 meters cubed. So that's $2 per meter cube, right? $1.50 per meter cube for anything that exceeds 75 meters cubed. So, and then there's a 5% discount on bills paid before July. So we are going to work out Mr. De Silva's bill, assuming that he paid before July the 7th. So first of all, we know that it's 105 meters cubed. So the first thing we have to do is say, well, the first 25, he's going to get for $2.50. So that's $2.50 by the first 25. Then, really nice and easy, right? Then after the first 25, he's going to have to pay $2 for the next 50. Yeah? So that is $2 by 50. And then they said anything that passes 75, you have to pay $100.50. So you're going to pay $1.50 for the remainder. And how do we find the remainder? We say 105 minus 25, which is actually 80, and then 80 minus 50, which is actually 30. So when we add up all of them, we are supposed to get 105 meters cubed. Yeah?
Can we add the 50 and the 25 and just subtract it from the 105?
Yeah, it's the same thing. Yeah, you could do that as well. It's the same thing. I just subtracted it. Yeah? So add them up and get the difference. So that will be 30, right? And all we have to do now is work out our total. So 2.5 by 25 will give me $62.50 plus $2 by 50. Of course, that is $100. And then plus 1.5. Then we have the 1.5 by 30, which is $45. And then we work out the total, which is 645 plus 100 plus 62.5, which is $207.50. But of course, that's the total bill, but he paid it before the 7th, so he's going to get a discount. So I am just going to work out the discounted price, which is just 100 subtract the 5% discount, which is 95% I have to pay. So this is going to be 95, of course, over 100%, multiply by 207.50, which is 0.95. By 207.5. I use this method. So Joshua won't say, so Miss, how come you didn't use that method and you're using my method? And you know, 197.13. So yeah. And of course we rounded to the nearest cent. It was 125. So we put 13. And this is his bill for the first half of the year, his WASA bill. Anyone has any questions?
So the three totals here for the first part. One is for the first 25, the other one is for the next 50, and the last one is for the remaining 75 meters. Okay.
Because anything in excess of that 75 is $1.50. So we just have to find out the difference that will make up our 105. So we say 105 minus 75. Moving on to electricity now. Let's learn some abbreviations and the conversions for it, right? So 1 watt, or watt, what we would know as a watt in electricity, or watt, is represented by a capital W. A kilowatt is a common K, capital W. Watt hour, capital W, common H. Kilowatt hour, common K, capital W, common H. Right, so we should learn the abbreviations: a watt, a kilowatt, a watt hour, and a kilowatt hour. Right, the conversion says that 1 kilowatt is equal to 1,000 watts. Right, 1 kilowatt is equal, 1 kilowatt hour is equal to 1,000 kilowatt hours, and 1 kilowatt hour is equal to 1 unit. Right, so if we have a kilowatt hour, they want us to do some conversions below here, right? You all have done the conversions already?
Yes, miss.
All right, so how many units of electricity does 5 kilowatt heater use in 7 hours? So of course, we're going to combine kilowatts and kilowatt hours, right? So for part 1, 1 kilowatt is equal to 1,000 watts. But 1 kilowatt hour is equal to 1 unit. So of course, if we have 5 kilowatts by 7 hours, right, that's going to be 5 kilowatts by 7 hours. So that is 35 kilowatt hours. Yeah. And remember, every 1 kilowatt hour is 1 unit. You're following me? Every 1 kilowatt, according to the conversion, every 1 kilowatt hour is 1 unit. So therefore, that's just going to be 35 units. Any questions? So we multiply the kilowatts by the amount of hours, giving us 35 kilowatt hours. Then to convert kilowatt hours to units, we know that every 1 kilowatt hour is 1 unit. So 35 kilowatt hours will give us 35 units. Let's do part 2. I'm going to come down here for part 2. 60 watts for 84 hours. So let's multiply 60 by 84, which will give us 5,376. All right. And they said, what was the conversion for what?
It's 60 by 84, right?
60 by 84. Yeah.
5,014.
5,376.
I see it on my calculator, 5,040.
Because you made a mistake. 60 by 84?
Yeah.
Oh, well, I probably made a mistake. What did I make a mistake with? Oh, in my calculator, I put 64 by 84. Nice. So 5,040, right?
Yes.
Nice, nice. So now that we have 5,040 watt hour, what do we do to convert watt hour to units? How many watt hours will give us? So we would definitely have to change watt hours to what? What will we have to change? Kilowatt hours in order to get the units, right? So how many watt hours are kilowatt hours? 1,000 watt hours, 1 kilowatt hour. So in order for us to find this, every 1,000 watt hour will give us 1 kilowatt hour. So we will divide it.
Divide by 1,000.
Correct. giving us 1, 2, 3, 5.04 kilowatt hours. And every 1 kilowatt hour is 1 unit. So therefore, this is giving us 5.04 units. Right, so remember 1,000 watt hours will give us 1 kilowatt hour. So we divide it every 1,000 inside of here will give us 1. So we divide by 1,000 to get kilowatt hours. Yeah. Part 3, 175 watts for 25 hours. So again, we say 175 multiplied by 24, which will give us, hopefully I have this one correct, for 200 watt hours, right? Yes.
Yes, miss.
And then we know that again, every 1,000 watt hour is 1 kilowatt hour. So we divide and that will be 4,200 over 1,000, which is 4.2 kilowatt hour, which will give us 4.2 units. Any questions there?
It's the
Any
same like the
questions?
previous one.
Part 2, yeah.
Yes, you get watt hour and then divided by 1,000. Okay.
Yeah. So that was the end of that example. Tiffany, you're with me, right?
Yes, I am.
Awesome. All right, so you have a bunch of different bills. We could do, I want to stick to the first one. Just like that.